Compared with traditional fixed-wing aircraft, gyroplane, have unique advantages, especially suitable for flight needs in specific scenarios. 1. Lower takeoff and landing requirements and stronger adaptability. Gyroplanes have extremely short takeoff, run distances usually only tens of meters, and some models can even take off almost vertically, and their landing distances are also much shorter than fixed-wing aircraft. They have low requirements for runway flatness, and simple sites such as grasslands and dirt roads can meet the takeoff and landing needs. In contrast, traditional fixed-wing aircraft rely on long runways to accelerate to gain lift and have higher professional requirements for takeoff and landing sites. This makes gyroplanes more practical in scenery IOS, lacking standard airports, such as remote areas and emergency rescue. 2. More prominent safety. The rotor of a gyroplane is in a passive rotation mode, which does not require engine drive and can maintain rotation to generate lift only by the impact of airflow. Even if the engine fails in the air, the rotor can continue to rotate through inertia and airflow, achieving a controlled gliding, landing similar to a paraglider, which greatly reduces the risk of crashes. However, if the engine of a fixed-wing aircraft fails, it needs to rely on a specific height and speed for gliding forced landing, which has higher requirements for the pilot skills and site conditions. 3. Easier operation and higher fault tolerance. The flight control system of a gyroplane is relatively simple, and it does not require complex wing manipulation, such as the finish, like fixed-wing aircraft, so the training cycle for pilots is shorter. Its flight attitude stability is stronger, and its crosswind resistance is better than many light fixed-wing aircraft, so the fault tolerance rate is higher when operated by novices, making it more suitable as a tool for private flight or primary training. For better low-speed flight performance, gyroplanes can maintain stable flight at extremely low speeds, even below 50 km per hour, and can fly at low altitudes in a nearly hovering state, which is suitable for tasks that require slow observations such as low altitude, reconnaissance, and sightseeing. However, fixed-wing aircraft have a minimum safe flight speed limit, and it is easy to stall below this speed, making it difficult to achieve low speed and low altitude operations. 5. Lower maintenance and operation costs. The structure of a gyroplane is relatively simple, without complex components such as wing flaps and tail control systems of fixed-wing aircraft. The mechanical failure rate is low, the maintenance process is simpler, and the cost of parts is also lower. At the same time, they usually use small displacement engines such as the Rotax series, which have lower fuel consumption than fixed-wing aircraft of the same level, and the long-term operation cost is more advantageous. 6. Lower noise and stronger environmental adaptability. Due to the passive rotation of the rotor and the rear-mounted layout of the engine, the flight noise of gyroplanes is significantly lower than that of traditional fixed-wing aircraft, especially models with front-mounted propellers, making them more suitable for flying in noise-sensitive areas such as residential areas and scenic spots. In addition, their adaptability to complex climates, such as light wind and light rain, is also better than some light fixed-wing aircraft. However, gyroplanes also have limitations, such as lower maximum flight speed, usually not exceeding 200 km per hour, and shorter, so they are more suitable for short-distance low-altitude flight tasks rather than long-distance transportation. But in specific scenery IOS, their advantages make them an efficient supplement to fixed-wing aircraft.